Welcome to MMT Ask the Expert. This episode brought to you by Husky, melt to mold precision. Today I'm here with Sheldon Alexander, Hot Runners and Controllers Business Manager at Husky Technologies, to answer some frequently asked questions about post-consumer recycled materials and bioresins. Hi, Sheldon.
Hi, Christina.
Let's jump right in. Have you seen an increase in PCR usage, and how does it impact hot runner maintenance?
Yes, we are seeing an uptick in PCR usage. PCR by its nature is more thermally sensitive than virgin resin. This requires a hot runner with a better than average thermal profile. In addition, it's difficult to get clean PCR, which requires a hot runner that is easy to maintain. The ability to remove tips in the machine to clean contamination, for example, is an important aspect of any hot runner system designed for PCR.
All right, so while we're talking about resins, we're hearing a lot about polycarbonate, especially in medical applications. So what has Husky's experience been with polycarbonate, especially for high-end medical parts? And what have your observations been on system balance for these types of applications?
For decades, the industry has struggled with PC applications, especially as parts are getting more complex, smaller, and higher cavitation. Husky opened an R&D project about 5 years ago to truly understand what it takes to be successful at molding polycarbonate. We learned many things from a system level, specifically how to optimize the hot runner for polycarbonate. As such, we launched a new product line specific for polycarbonate and heat-sensitive resins. Some things that's important is the thermal profile of the hot runner system, the design and manufacturing consistency, melt channel surface finish, steels, coatings. These are all important things from a hot runner standpoint. As we talked about previously, balance is very important for most applications, but even more so for small, highly engineered resins, and polycarbonate certainly fits into that category.
All right. What experience do you have with high temperature or corrosive resins?
We have a lot of experience with this market segment. With high temperature, insulating the electrical components is key. They're not really designed for the high mold temperatures that you see in high resin applications. With corrosion, steel and coatings is important. Stainless steel is preferred. However, stainless steel tends to be gummy or sticky. So when you have moving parts, for example, between the stem and the manifold bushing, it's a challenge to have those two components with stainless steel. This is where coatings become important and come into play.
Okay. All right. Can you provide some specific examples of a good use of bioresin?
Yeah, so bioresins along with PCR is certainly a growing trend, specifically in the single serve market segment like cutlery, knives, forks, spoons. Coffee pods are another good example of applications that we see a lot of interest in bioresins.
What are some hot runner considerations that are required when molding with bioresin?
There are many bioresins on the market and many more being developed. We are working closely with several resin suppliers to develop our hot runner alongside these resins. Many, like PLA, are corrosive. Others are thermally sensitive. PHA is one that really excites us, as it's neither corrosive or overly thermally sensitive.
All right. Thank you, Sheldon, for your time and insight. And to those watching, be sure to check out the 3 other installments of this special 4-part series on hot runner technology, brought to you by Husky Technologies, right here on moldmakingtechnology.com.